number of drive-in test attempts made by 35 people until they pass. Find the mode of the number of attempts taken to pass. Okay, so the mode is clearly 2. It's the biggest one. You can see that as 2. So let me just write that down. So this is A1A. The mode equals 2. Okay, and then the B part, the median. So there's 35 people, yeah. There we go. There's 35 people, so 35, that would mean that the median is at the 18th person. So the 18th person will be in 2 as well. So the median is equal to 2. So that's fine for A1.
What do they have it for? It's like 2 marks.
It's Christmas, I don't know. They're being generous, I have no idea. It is good for 2 marks. Yeah. Much easier than the last one where you have to calculate the mean, right? Yeah. Okay. 2, good old 2. A machine prints pictures onto drinking glasses, but it has an undetected fault, meaning that every 10th glass is not printed. They're packed in a box of 6. Find the probability that there are 2 or more glasses which are broken. This is the probability that if 2 of them are broken, that's the same as 4 of them not broken. If 3 of them are broken, that's the same as 3 not broken. 2, 1, 0 not broken. So that's the probability. Is not broken 0.1 or 0.9?
Not broken.
Yeah. Okay, so we don't want to do it this way unless we want to use our tables, you see, because this would be, well, I guess it's okay. We could say this is probability of 4 or less not broken. But the problem with that is that the probability is 0.9, and our table book is only for less than 0.5 is the most, isn't it? So we need to change this back. So this doesn't work. We need to change it back into broken. So I don't. Happening again. It's happening again. No, hang on. I just need to take a breath here. No. The issue last time was I was confusing broken, not broken, less and more. All right. 1 minus the probability of 0 or 1 broken. So this is 1 minus the table book with P equal to 0.1, N equal to 6, and X equal to 1.
But the question says there are more than 2 classes.
I know, which is the same as 1 minus less than 2. Because the 1 minus.
So is not included in the book.
I think it said 2 or more, didn't it? Very good, Malik. I didn't notice that nobody noticed this yesterday. Did you notice it? No? Excellent. It says more than 2, not 2 or more. So I should have started with 3. It says more than 2. Stupid English. Stupid English. You understand the difference between more than 2 and 2 or more? I didn't understand the difference yesterday. Disgraceful. Right, so that's so that means 0, 1 or 2 broken, so I just need to look up 2. Okay, so what do you get when you look up 2, please? 0.9842. So the answer is 0.1268. No? No, of course not. 0. Help the teacher out. What is it? 0.158. Thank you. I've never had so much difficulty with a question that was so easy. Okay. H3 then. I have a B? Oh, I do have a B, don't I? If you buy 4 boxes of glasses, what's the expected number of glasses in total that will not have been printed? So the expected number that will be broken. So the 0.1 multiplied by 4 multiplied by 6, because there's 4 boxes and 6 glasses. And 10% of them will be broken, a tenth.
But the bank is in 4,000, nothing before.
That 4,000 is not related to anything. I don't know. I think they put it in to confuse you, maybe. It's not required for anything. Strange. You don't need to use the 4,000 anywhere. It's odd. Okay, so what's this here? 22.4.
Why is it the possibility is 1
Say again?
Why the possibility is 1
Where am I looking? The last part of the part B? Part A? Yeah.
The P1 is 1.
Oh, this is the probability of it being broken. Yeah? It says a tenth in the question. You can't see the P, but it's on the second line. Okay, can I go on to number 3? The mean travel time for 45 employees to get to work . The mean of this is 39. 2 new people join, so you have 47, and now it increases. Oh no, sorry, they tell you how much each ones are, and they want to know what is the mean. Yeah, okay. So, you know the formula for the mean is the first person plus the second person, etc., plus the 46th person plus the 47th person over 47. Now, we know these last 2 here, which is good, but we don't know the other 45 people. So what you can do, you can look at this here. You know that x1 plus ... plus x45 over 45 equals 39. So if you bring the 45 up, what do you get? 45 times, oh, look at that calculator. 45 times 39, 1755. So that must be the total for everything here. Right, so 1755 plus 35 plus 60 divided by 47, and I get 39.4 if I do it like this. That's okay, isn't it? Yeah. Right, let's have a look at 4. Okay. You have 3 sets, A, B, and C. and you're told that the probability of A is 0.1, the probability of A union B is 0.7, the probability of B given A, which is the probability of B and A over A, that's equal to 0.3. The probability of C is equal to 0.2. The probability of C given A, which is the probability of C and A over A, that's equal to 0. And then the probability of C given B is the probability of C and B over B, that's also equal to 0. So if you look at these last two here, it tells you that the C and A and C and B both must be 0. So the C and the A must be 0, and the C and the B must be 0. But you also know that C must be 0.2, so that means here must be 0.2. If you know point A is you know that A is 0.1, so you know that A and B is 0.3 times 0.1, which is 0.03. So here, this is 0.03. A must be 0.1, which makes this 0.07, and A or B must be 0.7, which makes this 0.6 then. So by starting at the bottom and going up, you can work out the numbers. And the total makes what? This is 0.9, so outside is 0.1. So now I can easily answer their questions. Probability of A and B is 0.03. Probability of A or B or C is 0.9. Okay, got that? That's okay? Yeah? Okay. 5 now. Find the K. So you know that the total probability must be 1. So that's fine. 6, 7, 8 tenths plus 4/5, isn't it? 4/5 plus K must equal 1, so K is a fifth. That's part A. Part B, the expected value of 3x plus 2 is the same as the 3 times expected value of x plus 2, which would be 3. Sorry, I should get the expected value first. Well, I'll put in big brackets. So that would be, let me see, 4 times 3/5 plus 5 times 1/10 plus 6 times 1/5 plus 7 times 1/10. So let me see, that'll be 12/5 plus a half, that's a 5, 6/5 plus 7/10. So that's 12, 19, 24, and 48 tenths. 24/5. Is it 24/5? Great. 24/5 plus 2. So that's 48. 72/5 plus 2, which is 82/5. Which is 16.4. Is that okay? Did you get that? Yep. And then the last part for 5, part C, probability that x is between 4 and 5.7. That's the probability that x is 4 or 5. Which is 3/5 plus a tenth, so it's 7 tenths. Is that okay for section A? Where's my pen? can't see it. One moment. There we go. 7 times. All right. Let's have a look at section B now. How are we doing? Yeah. Okay. Good. B1. You have a Venn diagram. People who are employed and males. Use the Venn diagram to find the number of males. How many males are there? Well, that's 25 plus 46. So what's that now? 11. Whoops. 71, isn't it?
Yeah.
The number of people who are not employed and male. So not employed and male, that's 46 people who are male and not employed. Number of people who are not employed or male. So the males are 25 plus 46, and then not employed would be an extra 27. 98. Thank you, I'm being stupid. 46 plus 27. That's better. 73. Right, so that was part A. Part B, the males who are employed, male and employed. The people who are unemployed, who are not male, so unemployed and not male. The set of either males who are unemployed or people who are employed. So the males who are unemployed or the people who are employed. Oh dear. So there's 7 marks here. Pretty easy 7 marks, I think. Yeah? Right, now the C part is it normal distribution? Yeah. A company grows a particular type of carrot. It is expected that the length of these carrots will follow a normal distribution with mean 125 and variance 20. A carrot is rejected if it is smaller than K, whatever K is. 3% of carrots selected at random are rejected for being too small. Find K. Right. So we have our bell curve, and here's 125, and there's some point here K which is too small, and 3% are rejected. So we need to convert this into a 0, 1. So this will be 0, and this point here will be K minus 125 over root 20. Now we need to look up the table book, because we want to find 3% here. Well, the number that makes, it's going to be negative. So the negative number here. It's going to be the same as this number, which has 3% to the right, because it's mirror image.
So it's 1 minus.
It would be minus, what value gives us 0.94? No, 0.97. Alright, so what is the value in the table book that gives us an area of 0.97 now? What did you think? Okay, that'll do. That's a minus as well. K equals 116.5. Yeah, that's okay, close enough. Okay. Continue. Part 2. What's the probability that the caret will be at least 130 and the mean is 125? Yeah. So the probability that the caret will be bigger than 130, we need to convert that into a z. So that would be z is bigger than 130 minus 125 divided by root 20. So that is z is bigger than 1.118. Which will just be the table book value at 1.118. I don't think you can look up that. You'll have to look up 1.12. What do you get? Oh, no. It'll be 1 minus that table book value because, yeah. So what is the table book value? 1.12. 0.86. Okay. There's still another part for this. Yeah.
How did you get 1.12?
Yeah, I did 130 minus 125 over root 20. This is the Z transformation. Yeah. Okay, next one they want a confidence interval. So it'll be 68 plus or minus 4 over root 25. Because they say the variance is 16, so the standard deviation is 4. And I forgot 1.96. So on the upper side, 69.57. On the lower side, 66.43. Everything in between. That's the true mean. Could be somewhere in between. Did you get that? Or? Yeah.
Is a formula or something?
Is a formula or something, yes. Maybe you missed this class. I believe I did it one Wednesday morning at 9 o'clock. Possibly. In fact, I'm nearly certain I did. It's possible you missed this class? It's possible, right? Yeah. So you might want to get the notes from someone or watch the video or something. You're right, it is a formula for this. The lesson's called standard error and confidence intervals. I think it's in your book as well. Okay, can we go to the next one? Right, so slope, let me see if I remember. X, oh yeah, well, I always forget the n. nsxy minus sxsy over xx minus sx. Great. So they give us those information here. So the slope, let me see, the n is 9 times 21405 minus, let's see, the x1 and the y1, 485 and 552 over 9 times 31475 minus 485 times 485. So when I look at it, I should get a negative answer for the slope, which I do, minus 1.562. And the intercept, it's the average for the y, sy over n, minus the slope, or whatever letter we're using, times sx over n. So the intercept will be sy over n minus the slope, which is a plus then, times sx over n. Did you get? No, that's way too big. Oh, that's because I wrote multiply instead of plus.
Why they don't have this format?
They do, but they have it in a way that I don't like, that makes it difficult to use. Start again. 552 over 9 plus 1.562 times 145? Yeah, that looks about right. 145.5. So my formula is y equals 145.5 minus 1.562 x. What does the b represent? The 1.562 represents the slope, meaning that one increase in x sees a 1.562 decrease in y. Yeah, is that part okay? Tell me why you might not want to use this formula to calculate y when x is 140. Worst case scenario, if you try to use x as 140, what's the worst that could happen? Well, the way I see it, the worst possibility on the graph is that when you go out to 140, you get a negative value for x. And we don't know what y represents. Y maybe is something that can only be positive, you know? Maybe y represents ice cream sales and x represents temperature. Well, I suppose it wouldn't be going down. But you know what I mean? Like, we don't know if y can even be negative. You know, so it could be quite wrong to go as far as 140. So we don't have enough information to know if we are justified in going to 140. In other words, we don't know the behavior this far away. So you could say, there's many things you could say. One thing you could say is, we do not know if the line will hold true for x bigger than whatever the biggest number is, about 100. You know, we don't know what happens after 100. I mean, it's possible that the graph is actually like this, and it only looks straight. Or it's possible that it actually becomes very negative. You know, we just don't know the behavior, so we can't really say. Okay, use your equation to estimate y when x is 55. So y when x is 55. Let's see what we get. Um, 59.6. Yeah. One of the observed data pairs is x 55 and y 49. Calculate the difference between the value of y and what you estimated. So the difference is called the residual. I can't remember. Do I say true minus true minus observed, or observed minus true? Which way around do I put it? Predicted minus true or true minus predicted? I don't remember. I say predicted minus true, do I? I don't think it matters too much. Predicted minus true. 59.6 minus 49. Yeah? That's 10.6. Yeah. Okay. Oh, and comment. What comment could we make? Yeah. That there's a significant error at this location. The model produces an error of 10.6 near x equals 55. And then, you know, maybe there's some problem with the data, maybe it's not a nice straight line, you know, you don't know. Okay, next part. Now let's see if I remember this one for the correlation. It's n sxy minus sxsy. Oh yes, over 2 square roots, square root n sxx minus sx squared then, and syy minus sy squared. Okay. So let's see what we get for this then. 9 times 21405 minus 485 times 552 over square root times square root. The first one is 9 times 31475 minus minus 485 squared. 9 times syy 47204 minus sy squared, 552 squared. Quite negative, minus 0.988. Yeah. Mm-hmm. Nothing. I just got lazy. That's the only difference. So I should write sx. Are you asking the difference between this one and this one? Ah, okay. To the side. Right, so just so you know, sometimes I'm lazy and write this one. Maybe it's better I write this. And that is not the same thing as this. The difference is here, this is the sum of the x's times the sum of the x's. Whereas here, this is the sum of the x's squared. So in this case, we sum, then square. Whereas in this case, we square, then sum. That's exactly the difference. It's okay? Yeah. Right. Interpret your value for or. Say strong negative correlation. R squared equals 0.976, which means the linear model explains 97.6% of the variance, which is excellent. And there's one more part here. Now, when we look at the last part, we can see we were right not to use 140 because the Y represents the loans of music CDs from the library. So in other words, Y is how many music CDs were lent to people. So this definitely cannot be negative. It can only be 0. And X represents the number of burglaries in the town. So what they're saying is, as X increases, that means more burglaries. What happens to the lending of CDs? It just decreases. Why? So, any ideas about what we think is happening here? Maybe. So do you think that increase in burglaries, increase of robberies, means that the library will give people less CDs? Is that what's happening? What do we think is happening? I know. We'll do that EAP thing where you work in pairs. So I want you to talk to your neighbour for 1 minute. Yeah, it's her, I know. That's the look of the draw. I want some ideas, because in the exam you will need to write down an idea about what's happening. So maybe if you work together you might come up with an idea. So in 1 minute I'm going to ask each pair what idea they came up with for the explanation here. Okay, go ahead. What word are you checking? Robbery, thief, stealing, take something. What word do you use? Robbery? Okay, firstly, do you know what burglary means? It means to rob, to steal. Yeah. The question is, as the burglaries increase, the lending of the CDs decrease. What is happening? Why are the two related like this? I like it. That's also true. You two are finished. You have a plausible explanation, yes? Okay, alright. Okay, let's see what we come up with. So, over here, what do you think is happening? Go ahead, Tony, tell me. Go on. You had a good idea. Let me hear your idea. Yeah. Yeah. Don't go to the library. Yeah. So more burglaries mean more people stay at home. They don't go to the library. Good. Okay. What do you think?
Because the lender is a thief.
Wait, hang on. Slow down. The lender is the thief. But why is this is possible? But if the lender is the thief, then why does it decrease when he steals more CDs?
He doesn't have money.
He feels the CDs, there's not much to lend.
Yeah.
But he's the owner.
But he's the owner of the CDs to begin with. I don't. No, I'm sorry. I won't take this one. Okay.
I
I don't know.
You want to make a fake account?
Yeah, okay, we're getting a bit too creative here. What did the two of you come up with?
They're too scared to leave the house to go to the library, so don't see because they don't want to access the people.
Too scared to leave the house. So then what do they do? They don't go to the library. So the same idea then, exactly. And what about you two? Go on, Victor, yeah?
Mine's the library has been robbed, and now they don't have the same funds to them.
True. Yes, true. But for that to be true, you would need to assume that more house burglaries means more repeated robberies of the library. That might be an assumption too far, I think. I think
Depends the country.
I think you all missed what I thought was the obvious one, was that as the burglaring rate increases, that means the CDs which people have borrowed are also stolen, which means they are never returned to the library, which means the library is not able to re-lend them. So, yeah. You all had good ideas, yeah.
It's like, but your one is indirect, our one is direct. Like this.
True, but I think your one required another assumption, that when more houses are robbed, it means the library is repeatedly robbed. Which is possible, it is possible, but minimum assumptions would be best. So what we're saying is more burglaries means more stolen, borrowed CDs, which means less CDs returned, which means less re-lending of CDs. That could be wrong. That could be wrong. It could be that when the CDs are stolen, the library buys new CDs. Then this explanation is no good. And your explanation will be no good. And the only explanation that would make sense is their explanation that people are too scared to borrow CDs. So it's not like this is right, but I feel like this is the best explanation. Although if you gave me your explanation, and you gave me your explanation, and your explanation, I would accept it. Your explanation, I don't know. Maybe not this one. Okay, let's have a look at the next one. What's the next one? B4. Ah, yes. This one. Trying to figure out what program they use. Looks a bit Microsoft Paint to me. Anyways, comment on the shape of the three histograms. Okay. So we had a lesson on the shapes. What can we say about the first histogram? It is unimodal with no skewness. Okay, the second one? Yeah, it is unimodal, positive or negative, with positive skewness. And then of course the last one, we get the idea here. It is unimodal with negative skewness. Negative. Come on. That's okay for 2 marks, isn't it? Yeah. Okay, let's have a look at the next one. Can I scroll down? Okay. Part B. Emma has collected data on the ages of choir members in various groups. Below is the frequency table for one of the choirs in her study. Sorry, just the other thing, with the library one, I just realised, it's possible that there's no relationship between burglary rate and CD lending. Because I just realised, who borrows CDs from the library? Yeah, so it's possible that the CD rate is just naturally decreasing as more people download. And it's just an accident that the burglary rate is also increasing at the same time. So there could actually be no relationship. So I just realised who borrows CDs from the library. Nobody does, okay? Do you get what I'm saying? So I think it could also be a natural decrease that happened at the same time as a increase in the burglary rate. So it's just a pure accident that they look like they're related.
Can we say that in the exam?
Yes, you could say that in the exam. Yeah, that would be acceptable. Okay, it just jumped in my head. Right, construct the cumulative frequency table first. Okay, so let's make the table. Actually, you know what? I think I'll use Excel. It'll be neater for this. Okay. Loading. Your business assignment was due today? A draft?
Yeah.
What was the topic? Or you each had different topics?
Survey.
You had to do a survey? Oh, great. Did you get to use any of the words you learned, like random, simple, random? You decided not to use that vocabulary you learned in your business report. Because what else? No. Nobody said I used a simple random method. Well, good thing it's a draft. You could add it in. Did everybody do simple random or something else?
Actually, we all of it, like the classmates.
Then it's not simple random.
Yeah. We didn't use that simple method.
You just asked everybody in the group, wasn't it? So what's that? Quota sampling, is it? Anyways, just think about it, you know. It's a chance where you can learn and use your words. And did you use words like continuous, discrete, ordinal and nominal? No. So you very quickly decided to forget about that and have discussion, yeah? Okay. Right, now let's have a look at the tables here. This is the age.
We don't want to make confusion to Mark.
No, Mark's a smart man. He'll figure it out, don't worry. He knows these words. 30 to 30. These goes up in tens, doesn't it?
Yeah.
42, 49, 52, 59, 62, 69 to 79, isn't it?
Yeah.
10, 12, 18, 30, 45, 28, 7. Right, so we need here a upper boundary. That would be 19.5. That's the upper boundary. And then the next one would be 29.5. So if we just scroll that down. Okay. What's the cumulative frequency for the first one? 10. Second one? 22. The next one would be 18 plus 22. So you get 40 and so on and so on and so on. And that's part C. So make sure your table matches this. Or if you don't have it, you should write it down.
The upper boundary is like part of its cumulative frequency.
Yeah, you should technically use the upper boundary when you're plotting. Yes, it's recording. Yeah. It's still recording, I think. I'll upload it and I'll call it business tutorial or something. Okay, do you have this table? Okay, so the curve, the cumulative frequency curve, we put this one on the x-axis and we put this one on the y-axis. So let me make the curve for you here in Excel. Is it a polygon?
Yeah.
Great, thank you. Right, so it's a polygon, which means straight line, so it's like this one. On the title is, I don't know, B4, whatever. B4, cumulative frequency for, what else? B4. Right, the x-axis is age in complete years, and the unit, of course, is years. And on the y-axis is the cumulative frequency. And there's no unit, it's just a count total. How many? Right, so your graph, nice, should look like this. Okay. Not bad. That will do nicely. Where's yours? Ah, okay, so I think people need to copy this. Can you copy this? Can I go full screen? Let's see. We'll go full screen. Anybody remember how to make this full screen?
Edit.
It was under edit, file, view. It's not. It's weird. Oh, is it maybe because I have the graph highlighted? Ah. Yeah. There we go. Make it beautiful. You drew it? Show me. Where? Ah! What is that? It's like it crawled out of the ground. Come on. Show me a beautiful one.
Are we going to set the coursework today?
I forgot about that.
Straight up.
These are straight in between the points. Did I give you the coursework? No, I didn't. So you have no idea what it's about, or some idea. You have class tomorrow, don't you? No, you have some classes tomorrow, right? Yeah.
No.
What?
She won't be here. I won't be
You
here.
finish early, so I don't.
You can come by the office after lunch to collect the coursework. I was going to give it to Donal or Mark to give to you tomorrow. Later today?
Yeah.
Maybe.
But can you explain for us so we can finish the study?
There's explanations on the page of what you need to do. There's a bullet point of the things you need to do. So like point 1 is get some data, and I tell you what type of data to get. So I give you like, I want you to get 2 types of data, an X and a Y, like interest and inflation, unemployment, GDP, whatever, two business or economic, or something else.
Let's see what before going on the model and get the data.
No, you have to find a source, like statistics on some website. This time you are going to collect the data and analyze it. I tell you what things to do with your data. Make a graph, stuff like this. But it's your choice what data you analyze. It's completely your choice.
Do we have to describe like
Yes,
describing
yes,
paragraphs?
yes. Paragraphs and sentences with words. I know, so do I. But unfortunately, this is what you need to do for the assignment. We'll talk a little bit about it after I finish this question, okay? I'll show you it on the screen. Okay, you drew that? Yep. Right, now, from your cumulative frequency curve, what is the median, the lower, and the upper quartile? So the median, what do you reckon? I'd say it's about 53. Would you think the median? No, no, 75, 70, 60, what 52? What do we think for the median? Anybody? From that graph? What did you have, Tony, for the median? Median, yeah. So at 75. Go from 75, yeah, across and down. About 52?
Yeah.
Maybe 52, something like this. Okay. So I think the median is 52. The lower quartile let me see, 38, 39 maybe. And then the upper quartile 59? No, a little less. 58 maybe? I don't know. 58 or something. Okay, use your graph, calculate Q2 minus Q1, Q3 minus Q2. Q2 is the median, by the way. 52 minus 39. My goodness, I'm tired. 13, thank you. And then Q3 minus Q2 is 6. Right. Do you remember how to calculate skewness? Or maybe even not skew. Maybe we don't have to. Which is bigger? So if you think about it like this, you have Q1, Q2, Q3. Q2 to 3 is 6 units, and then Q1 to Q2 is 13 units. So in other words, there's more to the left of the median, immediately to the left of the median. There can't be more to the left of the median because the median by definition is 50-50. But what I mean is, near the median, there's more to the left. From quartile 1 to the median is bigger than the median to the upper quartile. So if I look at the histograms, which histogram has more heavier on the left? So is it going to be 1, 2, or 3? I think so, but I don't know. So I'm going to no, I think it's number 3, because if you look at the histogram on number 3, this here is the median, and if you remember that the area represents how many you have. So what was this distance was 13, and this distance was a small 6, but you want the areas to be the same. So, I don't know now actually. It's definitely going to be 2 or 3. Which one might it be? We can also get it, you think it's 3. Yeah, that's what I was wondering. Also, we can also get it from the cumulative frequency curve. If you remember, if it is positively skewed, the graph goes like this and flat on the top, whereas if it's negatively skewed, it's kind of flat and then rises later. So is it flat at the start or flat at the end? If I look at this, do Do you think this rises quickly? I don't know. Kind of a bit slow at the start here. Makes me think again it's number 3. Anyways, it's only for 1 mark, so if you don't know, take a guess. I'm going to guess number 3. I'm not terribly confident though. Okay. Lastly, use your cumulative frequency. How many people are 55 or more? So here's 55. So 55 or less is 100. So more than 55 would be 50. So 50 is my answer for the last one. Okay, let me show you the project now that you'll have to do. Dear. Don't make me sad. Right. Here's your project. I'm sure you're excited to know what it is. Yay. Firstly, it is worth 10%. The due date will be given to you. The holiday plus 2 weeks. Yeah, I think that's plenty of time, right? Right, so some notes firstly. Plagiarism will not be tolerated. If you plagiarize, if you copy some other assignment and say, here you go, here's my assignment, I'll just hope that you won't notice it's the same as that guy's. There will be a penalty in your mark. You'll lose a percentage of your grade. If you do decide to photocopy your neighbour's and pretend it's yours, you've been warned. The assignment must be typed. I'll say that again because there will always be one person who will handwrite it. The assignment must be typed. It must be your own work. You can get help from me. Don't ask me the day before it's due. I'll just laugh at your face, okay? So don't come up to me 4 o'clock the day before it's due and saying, so I'm having a problem with this assignment thing, okay? Don't do that. Don't do that. 2 days before, yes. The day before, no. The deadline is 9 a.m. After 9 a.m. on the day it's due, you'll lose 10%. 10% for every day it's late. The word count is 3 to 600, but don't go over 600. You can go a little bit over, but don't go crazy. Don't give me 1,200. Okay. If you're aiming for high marks, if you want the full 10%, I'm wanting to see 600 or a little more than 600. You know, if you gave me 800, great, that'll help your marks. There's no need to go over 1,000. You're just wasting time after that. And when the word count goes up, I notice the quality goes down. So we'll keep it less than 1,000. Full marks for full work and details, and include a reference. So what do you need to do? Right, so you are to write a statistics report that is to investigate correlation between 2 data sets. If you will study, if you will study economics at university, then I recommend you take good care of your report, as some universities will have you do a report like this as well. So if you do economics or business next year, you should keep this report because you could reuse it. It's recommended that you talk to your business or economics teacher for some ideas, but you can have your own idea as well. So, X is some data used in business or economics, like interest, inflation, sales, whatever, and Y is another set of data for the same situation, like unemployment, GDP, etc. I want at least 10 of each, X and Y, okay, 10 X's and 10 Y's. At least, more is better. So what do you need to do? First, write an introduction about your choice of X and Y, whatever it was, okay? Put this data in a table. Put X and Y in a frequency table. Put X and Y in a cumulative frequency table. Plot the cumulative frequency curve. Draw the histogram for X and Y. Calculate the mean, median, and standard deviation and interquartile range. Calculate the correlation coefficient, interpret it. Calculate the equation of the line, show and explain your work. Plot the data on a scatter plot. What does the scatter plot represent? How do you use it? And then write a conclusion. Is there a correlation between X and Y? What can we say about their relationship? So basically you're doing a little statistics report, and I'm leaving the choice up to you. It doesn't have to be business and economics. I'll give you some interesting ideas from other students in previous years. Some students did the size of a car engine and the price of the car. Some people did how much the footballer gets paid and how many goals they score. This data is very easy to find. There's definitely websites that tell you how many goals each footballer has scored, and you can easily check what their salary is, because it will be in the news about how much their contract was worth, okay? But it doesn't even, it could be any two things you would like to investigate that you feel might have a relationship. If you have no ideas, you can talk to Mark or Donald for some ideas about related variables. I don't think I'll get much work out of you for the last 5 minutes. Would that be right? Especially the last 5 minutes before a holiday. Yeah, that's fine.
Holiday for you.
Now it definitely is a holiday for me. Trust me.
Not holiday for us.
If you think, I'm much happier about next week than you